Hello, my name is Claude Robert, and I will be presenting the transcriptomic platforms that have been developed within the EmbryoGENE network, which is a Canadian-funded, NSERC-supported national network that is dedicated to the study of bovine and porcine embryos. So right here, what we find is in this next slide is the scope and topics covered by EmbryoGENE. And we want to look at the embryonic health by comparing bovine and porcine embryos that have been stressed through assisted reproduction technologies or through maternal nutrition. Within EmbryoGENE, we develop two platforms. So one to study the transcriptome, and another one to study the bovine epigenome. In this presentation, I will be presenting the platforms used to study the transcriptome. So this platform is also used to answer some basic question of what makes an embryo, what defines embryonic developmental potential or developmental competence, or embryonic quality. And as I said, the scope is also includes how embryo can cope with stresses, which are derived from the application of art or from maternal nutrition. Both bovine and porcine platforms have been published, so you can find the reference right here. And the for both platforms, an RNA-seq survey was done to survey the transcripts that were found in early embryos from oocyte to blastocyst, from good and bad embryos, from in vivo and in vitro produced. So we surveyed these transcriptome using RNA-seq, and what was found is that a wide contingent of genes that were found in these transcriptome, but also a large contingent of uncharacterized transcripts, which we believe are long non-coding RNAs. We also found some differences, some peculiarities in splicing variants and some embryo-specific splicing variants that have not been described elsewhere, and some 3' UTR length that differs between transcripts. So on both the porcine and the bovine arrays, probes were specifically designed to account for all of these different features. The platforms come with a full software suite, which starts with the LIMS that we call ELMA, which is EmbryoGENE LIMS and microarray analysis software. So within the LIMS compartment, what we have is a description of the experimental conditions that were performed to generate these samples. So we use this to generate the EmbryoGENE's database, which at term will be fully searchable to perform meta-analysis. We also have a QC module. We spike the samples, and what you can find here in the blue spots are actually the spikes. And what we're looking for is that these spikes form these tight patterns right there. Here in the red are the negative controls, which should be where they are in the very low expressed or very low intensity signals. We also have a probes that contain mismatches, and depending on the number of mismatches, we can see that the signals rapidly drop down. So a few SNPs, naturally occurring SNPs, will enable hybridization, but too many SNPs will drop the signals up to almost zero, which means that which ensures the specificity of the probes. Right here we have duplicated probes. We make sure that they have a strong correlation between them. And here in this correlation matrix, what we have is the correlation between the arrays. So we do technical replication and biological replication, and we use this matrix to see how the arrays are repeatable. Once the arrays pass the QC, it goes through data analysis software. Right here we have a flex array, which was developed in collaboration with Genome Quebec, and this software also does the background correction and all the pre-processing, so the normalization within and between the arrays. Once this is done, it goes through the statistical analysis to generate the gene list in the end that is used for downstream analysis. So this is a fully clickable, very user-friendly software that is used to generate different plots right here from a drop-down menu. And what you have over here, it's the list of differently expressed genes. Here we have the probe name, but we can add the gene names. And here you have the fold change and the different numbers that were used for calculation of the p-values. We often use these volcano plots to represent the genes that are downregulated right here and the genes that are overregulated in the contrast. And what we found right here is in the yellow dots are the long non-coding RNAs that are differently expressed depending on the culture conditions. So in conclusions, both these platforms are suitable for low input. They work well with one blast assist. They're fully independent platforms, which means that you can go from samples to publishable plots easily, and it can be done with the support of the information on the website. It's fully autonomous for simple contrast. So if you have one, two, or three conditions that you want to compare, it's very easy to do, and it's complete with a full suite of software from the LIMS to the QC to the pre-processing and data analysis. So right here is the people that are behind these platforms. So Isabelle Dufort and Dominique Gagné worked on developing the sample preparation protocols, writing the SOPs, and developing the bovine RNA-seq libraries and testing the platforms. Right here we have Dr. Julie Niminen, who was involved in the communication between all the people that were involved in developing the platforms. And here we have the people that were involved in developing the porcine platform. So generating the RNA-seq libraries and testing the platforms and refining the pig gene annotation, which was difficult to use at first. Right here we have all the people that were involved in developing the data analysis platform, from the LIMS ELMA, which was done by Dr. Jason Grant at University of Alberta, and at Laval we have Eric Fournier that worked at testing flex array and reporting and fixing the bugs. And over at Genome Quebec we had Mihal right here, who was working on adapting the flex array software for our needs. And we had voluntary students that worked on testing the ELMA and flex array. So with this, I'd like to thank you for your attention, and if you're interested in the bovine platform, you can contact either me or my colleagues right here, Marc-Henri Sirard and Dr. Julie Niminen, at these emails address. Or for the porcine platforms, you can contact Dr. Michael Dick or Dr. Stephen Tsoi using these email addresses. So thank you very much for your attention, and don't hesitate to contact us. Thank you.